Hello, in this video we will start off our GameGear coding with a Hello GameGear project. So to begin with, I'm going to assume that you've watched the videos on installing code blocks and setting up GBDK, in which I created a small project for the Game Boy. This is a useful starting project each time because everything is already sort of set up for us. So we will begin with that. So navigate to the folder where that was installed. Then copy that folder. Now you're going to want to create some folders now for your GameGear development. So we will paste this in here and rename it to Hello GG. Then rename the code blocks project to Hello GG. Then open that with a text editor and wherever you see Hello GB, change that to Hello GG. Then save that and close. Now open that in code blocks. Now we want to amend the makefile here. Now if you are watching this on Windows, you will want to change this line here to that there, or wherever you've installed GBDK. And then change the name from example to Hello GG and change the extension at the end of project name here to .gg. Now save that. Now one thing we need to do now is we need to change, or rather add some additional parameters after the text here, so that we tell GBDK that we are now targeting the GameGear. So the easiest way to find where these changes need to occur is to navigate to where you installed GBDK. Then go in the examples folder, go into the GameGear folder, into the smoke project, and then open that makefile with a text editor. Now what we are interested in is this line here, so copy that and then add that to the end of there, and then take this line here, copy that and bung that just down here and save. So all of this should be good to go now. A few other changes we need now is go into main, and now we do not need any of this. Obviously I'll show you myself setting this up, but the source code will obviously all be provided in links so that you do not have to do this. This is just to show you how to get all this done. So all of the header files that we include for coding with the GameGear are pretty much exactly the same as the ones for the Master System. Hence, they really are that similar. The only real sort of differences we need to take into account is the GameGear has different palette format, and the screen size is obviously a lot smaller. So now we have this, we should be able to build it. Bring that up. So that build, obviously there's nothing in there, so what we need now is we need some tiles. So I'll create some more things here for us. So if you've seen any of my other videos, you'll see that I always create this here, where it literally just contains loads of shortcuts to the tile IDs for the graphics, and it also usually contains external file locations and names for all of the graphics, which I usually use. So we'll have some of that, and then we'll get the standard boolean. And I'll set up a few custom data types. Now, what I'll do now is I will show you the tiles we'll be using in this project. So this is going to be our graphics for this project. We have a kind of pinball like there. If I alter the view a minute, this will make it a bit clearer here. So we've got our palette here, all 16 colours for our background tiles, and these will be 2x2 tile blocks for some of our example graphics. And then we also have a faux font set up here as well for our tiles. So this here is tile 0. Always leave that blank, because whenever you clear the screen or whenever you have nothing on screen, tile 0 is what is displayed everywhere. And then I always leave this tile, number 32, empty as well, as when you work with fonts, 32 is the tile number for the space. So I usually always leave that. So those are our tiles. I will provide a link with the graphics as well for you to use. So now what we need to do is we need to actually create our graphics. So if you have downloaded my graphics converter, then you may be familiar with what I'm about to show you. If not, I recommend you grab it for creating various graphics. So here's our tiles here. There's 128 of them in there. So I will now open up a terminal window. Navigate to our location. If you're doing this on Windows, you obviously do not need to have a dot and a slash there. This is just a Linux thing. I almost forgot. as we're working with the GameGear, we need that. So 8x8 blocks and 128 tiles. So now that I have those, I need to create some variables to hold them. So we'll go into graphic defines here. And add in some constant variables for our fonts to begin with. So what this here usually means is that's the graphics, that's the tile starting position, and that means how many tiles it counts. So if you go to add any more data onto the end, you can literally just use, so for example, say I had an image or a title screen graphics or something. If I needed to know where to start this, I could just do tile start plus the tile count, and then you can keep going adding things on as long as you make sure that every time you have a tile start, you have a tile count variable to go with it. That way you can keep track of all the tiles that you have. So you always have an array for your palette and all your graphics tiles. So all the graphics tiles are bytes and all of your palettes are words, or U16 as in unsigned short or unsigned car. So now we need a source file to go with those. So always keep it simple. So here's our 16 colours, and here's all of our tile data. So now that we have all of these set up, let's create some helper methods, or functions, sorry, to make things easier for us. So I'll copy and paste some of these in. So most of the stuff you can probably use from the Game Boy and Master System. Most of the code for them that I've used will be the same sort of layout. So these are all of the commands we will use to start off with. So the tile data format is exactly the same as it is for the master system. They both use 4-bit per pixel tiles. If you've seen the master system ones, you'll see that I've changed the name here slightly, and that's because we need to pass it an array of U16s rather than bytes. So all this here does is it just will fill the visible screen with tile 0 to blank it out. So one thing to notice as well is the difference with this is whenever we draw a tile, it takes an unsigned short, and the reason for that is that the screen on the GameGear takes 2 bytes per tile. One is for the actual tile ID and the other is an attribute byte, which can be used to mirror the tile or change the palette that it gets its colours from. So all this command here does is it just loads in each colour from the palette here into the palette entry in video RAM, starting at palette start. So palette start should be either 0 or 1. It's the block of 16 colours, and then the colour count is how many to load into memory from the array. And then we'll use this command here. So this isn't used on the Game Boy Color or the Game Boy at all. This is a special command which GBDK sets aside just for the Master System, Game Gear and the NES. Right, I think that is, oh no, one more command. Can't print hello Game Gear if I don't have a command to actually do any printing. So this does write into the screen a bit differently. What this command here does is it gets the background address from video RAM where the tile location is. Make sure I pass the right things in there. Right, so we first get the address and video RAM of where the screen is. We're then assigning px, which we don't need anymore, to the first byte in the message here. Then while the value of px is positive, we then write 1 byte to the address returned here. This is a quicker way to draw tiles on the screen. But like I said, one thing to be aware of is because the screen RAM, video RAM, takes 2 bytes, we have to increment this address here by 2 each time to get to the next tile location. We then read the next tile ID from the character string, then increment the character string, and then we carry on in this loop. So I'm not checking here to make sure that the printing is within the tile map location, so be aware when using that to keep your strings so that they only display on the width of the screen here. So now we've got that. Let's include the graphic defines. Now at the start here, oh yeah, we also need to include the utilities header as well. So now first off we'll clear the screen, then we'll set the tile data, pass in the tile ID from the start of the fonts, pass in the count of the fonts, then the array to the data. Then we'll set the palette. Palette start is 0. We've got 16 colors, as you can see here. Now let's pass in the font palette. There we go. And 2 by 2. Oh yeah, we can include the utilities function in there so that it knows what these data types are. Okay, let's try again. It's because I've been copying and pasting from another project. There we go. So let's find where this is now. Now let's open that in Emulicious, and there's our text. So if we go into the tile map viewer, that will just show us the screen, which is centered, it would appear, on the tile map. Okay, that's something I wasn't aware of before. Now if we have a look at our tiles here, we can see them all loaded into a tile bank here in video RAM. So I'll quickly draw some of those for you, and then we will call it a day. So first off, let's bring this back across here so we can see where they all are, so we can create references to them. So we've got like the pinball like graphic there. Not really sure what to call that. I'll just call it that. So each tile of these takes 4, so we know that it's equal to UDG pinball plus 4, and then we'll add a U after these numbers to let the compiler know that we're using unsigned bytes. Now we've defined those, we should be good to draw some blocks. So I'll create some temporary variables for us here. In fact, let's draw a load of them. There we go, so they look pretty good. Now, one other thing I was going to do as well. Quickly see what this looks like. Now, because of the way I've organized these colors here, we can do an interesting effect by changing the colors in a certain area in the palette. You can create a false animation using just changing the colors. It's like color cycling, it's called. If we have a look at the palette here, so this is our palette here, so these 3 tiles here are what makes up our water tile. So if we copy this one to the end here and move these others along, then we can simulate the waterfall falling. So let's do that. Or rather, what we can do I've copied a few more bits of code in here to accomplish the color scroll off screen. So this here will accomplish our scrolling of our colors. So we will hold 4 colors here, which we will copy from the palette location here. So this is color 10, 11 and 12 here. So we will copy those here, this line here, so I've put some temporary variables in here to enable us to do that. So first what we need to do is we need to copy those colours from our palette font into our temporary variable here. Now what we will do is we will scroll these colours inside the temporary palette, and then we will copy these three colours back into the palette using set palette entry. So the colour starts at 10, which is where we will copy it back into using this loop here. So what will happen is, I tested it out first, and the way I described it was the opposite way around. What we actually need to do is to copy colour, this colour here, we copy this one, which is 12. We put that colour in our temporary variable here. So first off, in our palette scroll here, this is a temporary variable to hold one colour. So we take the colour from palette 2, which at the start will be this one here. Then what we do is palette 2 copies the colour here, so this one moves to there, and then we copy this colour here to there, and then this colour here then gets copied back to there. And that's what this here does. And if we keep doing that, then the colours will appear to loop around, creating the scroll effect. What I've also done here is I've changed the top message to using GBDK 2020, and I went ahead and added some more waterfall graphics in as well, because the scrolling actually looks quite good, and I played around with this command here to slow down the scroll effect, and then this line here calls our palette scroll after it's waited 60 ticks. Now if we build this, in fact one thing I forgot to do was to print out the bloke. So let's say let's put him in the center there. Now if we build this, then run this with Emulicious, you can now see he's in the middle of the waterfall. So you can create some good effects with the palette scrolling method. If you've noticed in games like the original Sonic the Hedgehog on the Mega Drive, there was some palette scrolling with the waterfalls on that. So this is the lot for this demo here. I'll post a link with the source code for this for you to have a look at. There's no reason why I couldn't have used these water scrolling effects on the Game Boy or the Game Boy Color. It would be a bit more difficult on the Master System due to its limited colour palette. You also wouldn't really want to do this on the normal Game Boy. Game Boy Color, as this tile uses 3 colours, that would work fine. But anyway, that's it for now.